that turns off, let me know.
No, not really.
Nessie's recycling.
Okay, all right, real quick here, we're gonna start notes in section 1.1 today. We're gonna finish it up tomorrow because it's just an intro section. It's reviewing Algebra 1 facts, just some basic stuff that you probably should know, or just hopefully you can remember. So today you can see I have a piece of graph paper in front of you. If you like graph papers, you can keep tabs where the notes are. I have a whole folder in the back. If you see where that little basket is next to the pencil sharpener, it's just below it in a folder that says graphs on it. I have a bunch in there if you'd like to get some. I know some people like it, some people just go, I'm just going to draw it for you until the... So, you can go grab it. I just don't want to walk around and hand it out. You guys can grab it. Okay. Okay, all right, now, here's the sections we're covering today.
No, I'm good.
One or two. We're going to do one or two.
I can't wear all my crafts.
All right.
Dude, I brought the vlog though.
Yay.
Where's mine? I want graphic.
Oh, I put the box.
Oh, I got
Oh, we got some safety precautions on
Okay, let's go through the definition of a function to begin with. Then we're going to get into linear function, which is why you have graph paper in front of you. We'll go through the basics on that, real basic stuff. Then I'm going to end with kind of a challenge question that I want you guys to take overnight and work on it and then bring it back. Even if you don't solve it, it's fine. It's just a challenge question to see what you guys remember and what you guys are capable of doing on your own. It's not like super difficult. It's something you guys should be able to do. Okay? But I think it's kind of fun. It's going to be a fun time to tomorrow. Now, here's the idea. A definition of a function. For every, this is what the book says, for every input, there is exactly one output.
Oh, we've done this before.
Yep. So again, it should be just a simple reminder of what Algebra 1 taught you. I think of a function like a machine. It's like a calculator. You type stuff into a calculator, so you do some entry, some input into a calculator, so this is your function. You do some input into that calculator, and that calculator better spit out one output. It should not give you two different answers depending on the type of date you typed it in. Now, granted, there's some fancy calculators out there that will give you more than one option, because maybe the problem is, it's a quadratic where there is two potential answers. There's some calculators that will give you both, but it's not going to make the conscious choice of going, today I feel like giving you one answer versus the other. It's programmed to give you one output, as long as there is only one output. Most calculators will say like domain error if you can't enter the number in the first place. Like if you had this function, 3 plus x squared over x plus -4, you can't plug in 4 into that problem. Why can I not plug 4 into that function?
That'd be divided by 0.
Divided by 0. Can't do it. You can't take something and divide it into 0 parts. The minimum you can have is 1 piece, right? You can't divide it into 0 pieces. That doesn't happen. So the idea is that it would give you a domain error because your inputs were wrong. Outputs, on the other hand, that's where it would give you some type of error because maybe your calculator can't display the number it's trying to pump out, right? That's where an error would come out. It's not your problem. The calculator ran out of memory sometimes. There's a limited memory chip inside of it. It's, a couple kilobits worth of memory. It's not a lot, and it will spit out the number if you're trying to do something big. Like for instance, if you're trying to do 999. And you're trying to put it to the 32nd power, it's not going to be able to handle that because it doesn't have enough memory to calculate it. It'll round it with some E number.
No. 9.6849.
Now, what is the power it's putting on it?
So 95th.
Oh, so I was close. So let's go with 35th power. Let's just change the power like a couple.
999.
Overflow error.
Overflow. Okay, there.
Whoa!
The memory ram.
Okay, will you give me a little bit of a
34.
comparison with like kilobits and like gigabits and like terabits?
Yes.
Okay.
We're good.
33 is 98.
I'll do that quicker now.
That's
What's
as far
the
as it
name of
goes.
this chapter?
Section 1, it's all about functions.
So there's no name to the chapter?
No, it's just functions.
This will
Yes, please.
You said it was a section.
I said it.
You said it was a
Okay.
section.
Now,
You said section.
so I was close. 34th or 35th
You said-
would have been.
That's the
Okay,
section.
all right. Now, okay, the question was that I had, what's a kilobit? What's a megabit? You know, that type of thing. So, the idea is that if you had memory on a computer, and you had 1 megabit, 1 megabyte, you would have 1,024 of those.
I don't think it's
1,024
making 1,000.
megabits. That's going to give you a gigabit,
What's a gig?
a gigabyte. So gigabyte, and like your cell phones probably come with like 64 gigabytes now. So you get 1,000 to make 1 gigabyte, and then if you have
Megabyte is the same thing as a gigabyte? No.
gigabit's different than a gigabyte.
Bit.
Wait,
What's
wait,
a gigabit?
wait, what's the
Gigabyte,
difference?
gigabyte.
Yeah, I thought you just said they're the same.
No, gigabits and gigabytes different.
Oh, so a
What's the
gigabit is the
difference?
same thing as a the MB one?
Megabyte?
The megabit?
Megabyte,
Okay.
you get 1,000 of them, you get a gigabyte.
Oh.
If you're in bits, you're even smaller than that. Bits are like kilobits,
Oh.
megabits, then it goes up to megabyte, then it goes, yeah.
Just think of a
So we're
picture.
really small. Like the memory in your calculator is like really tiny.
Pretty sure my phone was-
And now you're at a gigabyte. So then you have 1,000 of those, you'll make a terabyte.
Wait, are we at gigabyte? Gigabit?
Gigabytes.
What's a pentabyte?
I'm so
Okay, how many-
confused.
I thought it was bit, byte.
What?
Gigabits and gigabytes are not the same.
Now, so gigabyte.
A gigabyte?
No, gigabytes are small, gigabits are big.
What's after the pentabyte?
So,
No
I
idea.
think you just flipped it.
so.
Alright, now,
That was pretty sure you flipped it.
1,000
In my
gigabytes.
head, I'm like,
No,
I thought bits,
gigabits.
bytes. Now it's bytes, bits.
Word, like,
What's a
all
bit
this.
then?
It goes bit and then byte.
Bit that one? No, like megabyte, gigabyte, terabyte.
Good lord, bro, you not paying attention? He said there's 1,000
Lord, your shoes.
gigabits in a gigabyte.
No,
It's
no,
just
no,
a bit
no,
like-
you weren't listening, ask him.
Isn't there a thing
That's
that
a
says
very
You need
risky
brown
thing to
glasses
say.
though. Do you have glasses?
They're over there.
you just said there's
You got it.
1,000
Close it
gigabytes in
You
a
gotta get
gigabyte?
and a terabyte.
Why are we so confused?
Did you forget?
1,000 gigabytes and a terabyte.
Yeah.
So how
No,
Wait
what's
for
a
it.
gigabit?
Oh, okay.
Gigabits are small, gigabytes are big.
See? There is.
There you go, Ward.
It's a bit.
Now the fit is.
Bits,
The
bytes,
Megabits,
fit is fire
megabytes,
now.
gigabytes.
Okay, now, hey, real quick.
Gigabyte.
Okay, now, we're on input output, right? The idea is that most people in Algebra 1 were up to this point where you have inputs and outputs, right? This is something that they try to teach you in Algebra 1. They try to get you to kind of master it before the end of the year, where you graph. And they spend a long time, almost too much time, talking about the different ins and outs of drawing a linear function, where these objects are the things you control. You control the m, which is your slope. You control the b, which is your y-intercept, and it will spit out, different graphs. Okay, now the idea here is what I want you to know today is not only how to draw, if I were to throw different numbers in there, but what number affects what, because that takes us to a little more pre-calc level and algebra 2 level. So, like for instance, if I wrote y equals 1/2 x.
No.
What does that mean?
Rise
So-
over run.
Okay, good. Rise over run. So the idea is that the 1/2, this is rise, and this is run. Okay, well, this is why we're doing it. We gotta refresh. Yeah, it's been a while. Now, rise and run. We rise 1, we run 2, and I always go to the right. You can go down and to the left. It's just, I think of it as like positive slope is always going up to the right. It's the same idea. It's rising. The function is increasing monotonically, where it's going up the entire time. It's never changing. It's just being constant the whole way up. Right? Now, the number in the back on this particular problem is a 0. Right? That's my b number. That means I'm starting at 0, on the y-axis, because again, that's why it's called a y-intercept. The y-intercept is where does it hit the y-axis at? What specific number? And then from that dot, that's where the slope goes. It's
Can
going
your
up one,
attention
over
span
two.
go down?
What was that?
Can your attention span go down?
Yes.
Yes.
Like over
Yours has,
14?
Yes.
Yours has,
I
Now,
think mine's at like 2 seconds.
I'm struck.
so we're going up to the right. We're going rising, run one, running two, rise one, run two, and you get the idea. Now I can go backwards and make both numbers negative because two negatives still make a positive. So I could still be dropping one, running back two, drop one, run back two. It's the same thing. So I want you to know both. They're the same. The two negatives would cancel. It's the same as a positive slope. It's just which direction you're going from that y-intercept. Now, this is a linear function. Now, why can I draw a line here? Let's talk about that from Algebra 1 fast.
Straight.
It doesn't stop.
It doesn't stop.
Every single point between is a number.
Yes, that's the main reason. Number one, yeah, it doesn't stop, but every number counts. What? You can if you want, sure.
You don't have to more.
Yes.
You have 4 graphs. We're on the graphing twice today.
Oh my God. Now, here's the idea. So, the idea is that on a linear function, all the numbers count. That's why it's a solid line. The other thing that gives it away is it had an equal sign. That's from Algebra 1 class. An equal sign means the line is solid. If it was a less than symbol or a greater than symbol, the line would be a dashed line, and you'd have to shade half of the graph. Because half of the graph would actually work in that problem. Yeah, they're called half planar problems. Yeah, again, on that type of problem, there's a larger number of inputs because you're not limited to the line. You have a half of a plane that you can plug in. That would work. Now, questions on the basics that I just walked you through.
Not really.
Okay.
As a random.
Okay. Now, not every problem will start in that form. You know, that's called slope-intercept form. It's got slope, it's got an intercept, it's pretty easy. If you're in a different form, just rearrange it so it looks like that one. Move the constant over, divide by the number in front of y, so that it will get to look like that number. So like for instance, let's say that my problem, and again, you don't need to draw this one, I'm just gonna make the same problem. Let's say that this was my problem. Let's say that was my problem. Well, I would move over the x, because there's no constant over here, so I'll leave the 8y where it's at, and I move the x over. It become positive, because when you move a cross equal sign,
Divide by 8.
and then you divide by 8, right? So you divide by 8, everything divided by 8. And so the y's would cancel out, or the number in front of the y would cancel to be 1, that'd be the leading coefficient. The 0 divided by 8 is still 0. And the x, 4 divided by 8 is still half. It's still the same problem. So, the idea is that just simple, starting with like a different form, this is called standard form, ax plus by equals c. You could get it to the form that we want so we can go graph it. Because think about back to Algebra 1. They spent too long teaching you different methods, but then they forget to teach you why do we have them. Like this form is great for graphing. It's great for a visual aid. I want to go look at where the data is going. I want to predict. This form is really good for a story problem, right? I can read the story problem and set up the problem what it needs to be, and then I can rearrange it later to see what the data is telling me.
When we were probably supposed to be learning this, we were playing cribbage, actually,
Okay.
for our semester.
Yeah. Let's not do that. All right. So,
We never actually learned how to play cribbage either. That's
okay. Go. What?
On your
Wait, no, no.
computer, it was on your computer, it told you what to do.
Now, okay. So, now, I know I went through a little bit there, but is there any question on any particular aspect you were confused on that?
Not right now.
Okay, now, here's the idea. What I want to get to, and this is the part I said earlier, I want to talk about how do these numbers affect your drawing. So, for instance, if I were to just change the y-intercept, it would be the same line, it would just be shifted up or down. So, like, let's say I were to plug in a 7 here. It would be that line just shifted up 7, starting at 7 up. That would be the only difference. So it's a vertical shift. So y equals half x plus 7. It's the same line, we just start at 7.
Go.
7's here, I think. 1, 2, 3, 4, 5, 6, 7, yes. So 7, we'd go up 1 over 2, up 1 over 2, and you get the idea.
And they're parallel.
Yeah, it's the same line, they're parallel, because the slopes are the same. Now, if I wanted to turn the line, instead of, having it going up to the right like that one, if I want to actually like take the line and rotate how it's tilted, that's where you change slope.
Yeah, that's X.
So that's X. It's called a scalar multiplier. It's a, what do they call it? They call it it's proportionality. It's where when you change the proportion of it, the fraction in the front, all it does is it tilts the line in a different direction. So, I can have a certain multiplier. So let's say instead of half, I multiply by -4, let's say. If I were to multiply this fraction by -4, here's what would happen. And I'm going to go back to the original one. If I were to multiply by -4, here's what it would turn into. Now, I'm ignoring the 7 rule right now. So if I were to multiply by -4, here's what it would turn into, right? That slope. That was a terrible catch. Receiver, does he have to have good hands?
Good night. Go to bed. Go home. Go home.
All right. Anyway.
Not a receiver, but it's okay.
I'm not.
Facial expression.
All
They
right.
just hand it to me that way.
All right. Now. All right. Real quick. If you change the slope, it'll go a different direction. Now, what I've actually made on this particular problem, since I changed it to -2x, I made it a perpendicular slope. Slope that went the complete opposite direction will meet my other line at 90 degrees. Instead, being up 7. All I did was change it, so now it's going to drop 2, run 1, and it will look like this. It's at a perfect 90-degree angle from the other one. Perpendicular. All right. Now, I've done a lot there. Done quite a bit, kind of restructuring some of the stuff you've learned earlier. The last thing I want to finish with, and this is the challenge question that I want you to take from today to tomorrow. Now, this is where you might want to graph a piece of graph paper. So we've done, effectively one picture so far, right? Maybe you have some manipulation on that picture, some different drawings. This is the second one. I want you on a new graph now, and this is the challenge question. So,
Can we keep it in our notes? Do you want like a separate?
yeah, that's fine. No, you can say your notes. I'm not going to ask you to turn it in.
Okay.
It's just the question I want you to leave with, so you can kind of work on it, and then tomorrow that'll drive our instruction tomorrow. So here's the question.
That'll be the front seat.
Okay, here's the question. All right, so what I'd like you to draw is right on the graph. I'd like you to draw the y equals x squared graph. So now I'm going to help you draw this for right now. The parabola graph will always hit. So if you were to plug in like 0 and square it. So if I were to plug in 0 for my x and square it, I'll get 0, right? The 0 squared is still 0. So that'll be that dot, 0, 0. If I were to plug in 1 and square it, I get 1 out of that thing. 2. And if I were to plug in -1, if I were to plug in 2, you square it, you get 4, right? And so this is the quadratic graph. You can plug in negatives, it just looks like a bowl, it's a parabola.
I hate those.
So is that the kind that's gonna be?
Okay, I want you to draw that right now on your graph.
That.
Draw that graph.
0.
So it's hitting 0, it's hitting 1, 1, -1, 1, it's hitting 2, 4, -2, 4. That's the quadratic. Now, if I were to have a line, so I'll let you draw that, and this is the challenge question. If I were to have a line that's in that graph, and it was crossing that parabola, let's say it was hitting at 1, 1. So my line is hitting at 1, 1. And it also, that line also has a y-intercept of 4. So the line's looking like this, right?
Oh, shoot.
Hold on.
Look at
Screensaver
that.
went on. All right. So it was hitting 1, 1. and it was hitting 4 on the y-intercept for that line, that blue line, I want to know, where did it hit the line, the curve up there?
Okay.
That's the question I want you to take home. That's it. Where did it hit way up above? Where did that line hit the curve on the other side?
Yeah,
It
that's
hit,
not that hard.
it hit 1-1. I agree. It's not hard. I just want to see what are the different ways you can find it. Are you going to be that person who just counts back? That's fine. Are you the person that maybe you set up a formula and you figure it out that way? But you agree, it will hit, right? I just want to know where it'll hit.
I thought drawing the graph was the challenge question.
No. It's where will it hit up above. So again, the curve is the x squared graph. The line is hitting 1-1, and it's also hitting the y-intercept of 4. And I want to know, where did it hit the curve up above?
Is it like 3-9? Is that the next spot?
For
How far up? You go, you go one
for the
way.
curve?
Yeah.
Yeah, 3-9.
I was right, right?
Yeah, 3-9 is the next curve spot. For the,
Hold that one, bud.
What a genius. Is it this?
don't know. Think about it.
I think you do know.
So it's like not on the chart.
It doesn't have to be. I'm just giving you the visual aid, so if you want to be the person that counts, you can do that. I don't know if the graph will necessarily be your saving grace. So I kind of want you to figure out maybe there's a formula way of doing it.
Yeah, I got it.
Okay, because what I'm doing is I mixed a little bit of algebra 1, and I threw in a lot of like algebra 2 and pre-calculus. So I'm just kind of throwing you in the deep end a little bit to test the waters. What do we know? What can we describe? How can you explain it to a neighbor?
Therefore,
It seems devilishly easy
Huh?
until you actually look at the different ways to
It's not full.
See, I'm accountant man.
That's fine, you can do that, and it works.
What's it take to get to 1 to 4?
Jamie, start throwing your Sharpie at me.
Start at 1, out of your world.
Yes. Left hand.
Yeah, I can.
No.
That's
Oh,
what
my
I
bad.
Alright, can I get rid of the drawing?
Yes, sir. I'm trying to find the answer.
I'll leave that.
Oh, I don't know how to find the answer. I just got the formula.
I'm just gonna turn off the camera,
you
that's all I'm doing.
formula.